So, good evening, everyone. So, till now, what uh, we've seen is everything related to some sort of classical techniques in machine learning, where you have to sort of, what I would say, give some features as input. Features are sort of handcrafted, where you collect data from some real life experiments, say that okay, this is the age, this is the height, this and this and so on. And and you collect features according to the task at hand. Let's say for like credit card fraud transaction or something, you collect number of words and like number of words that can relate to fraud, where is the location and everything. These are all handcrafted features, but this is very hard to collect, and this is where deep learning or neural networks come into play. And here you can just give the text of the email. You don't need to count any occurrences of certain words. The neural network learns all these during the training process. So this is one advantage of neural network. But the problem is you can't go back and interpret like which word uh, sort of gave me this prediction, led me to this prediction, and so on. It's a bit difficult, but it can be done. So there is always a trade-off between what I would call interpretability and sort of easiness in feature selection, collection, and so on. Okay, this is what people say. Neural network. It's an inspiration from the human brain. It's modeled after the human brain, where there is a connection between different neurons. Okay, and what these are essentially is a weighted linear combination of feature values. So this is this one neuron. These are different neurons. Initially, the input layer, each neuron corresponds to one feature value, and you sort of do a weighted sum. Like each feature is associated one lambda with one lambda value, saying that okay, this feature is more important, this feature is less important. In machine learning, you have to do this manually, but in case of neural network, all these weights are learned automatically. Okay? But these linear models cannot learn any complex representations. Okay? Complex representations, meaning like if you have some data that can be separated by a straight line, this can work. But if there is a model which you need to have sort of curves in the decision boundary and so on, you can add a non-linear function. Okay, and this is what's there. You have some non-linearity in the neural network so that it can represent more and more complex functions. Some terminologies in terms of neural networks, where the circle ones you see are neurons, the arrows that you see are connections. Okay, each neuron is connected to every other neuron in the previous layer. Okay? Very similar to the human brain that we have. There is no. This is the input layer. This is the output layer. So here you have three features going into the network. You have a single layer. This single layer neural network, and you have two outputs, okay, for zeros and ones. Okay. These are connections. Each connection is associated with the weight, as I told you before. This is the input layer, this is the output layer, this is the hidden layer. Okay. We only have one hidden layer, but you can have like multiple hidden layers. You can have one, two, three, that depends on the function or complexity of the task you have at hand. Any doubts till now? Okay, what else? Moving on. So essentially what happens here is at this neuron is weighted sum of these three features. Here you have different weights, again weighted sum of these three features. So that's what's happening. This is called a perceptron, and then you have an activation function and you get an output. Okay, and that output is passed to this neuron and this neuron. Okay. So you want sort of like a curvy decision boundary and so on, you need to have some activation function. Some choices are tan h, or it can be sigmoid, or it can be a ReLU function. Okay, these are all equations. So ReLU function is, you don't, if you have a negative value as input, it will be 0. If you have positive values, it will be the same positive values. Okay, most neural network architectures use the ReLU activation function. Okay, so this is how the curves, you can keep adding these functions again and again, and this is what essentially brings the nonlinearity into your neural network. Any doubts in activation function? Sigmoid, again, same thing. Everything is between 0 and 1. Okay. And tan h, it's minus infinity to infinity. It's just a more smooth curve that you have here. The range here is 0 to 1. Here it's 0 to infinity. Here it's minus infinity to infinity. Okay. Okay. Again, why is the name deep learning? Because instead of one layer here, you can have multiple layers. And you can see how complex the connection get. Okay, like this 3-layer deep neural network. So can anyone tell me how many input layers, how many output layers, and how many hidden layers are there in this network?
So three hidden layers.
How many input layers?
So one.
How many output layers?
One, sir.
Okay. How many features are there as input?
So five.
How many classes as output? How many outputs? There is only one output that you get. Okay. And this output can be between 0 and 1. Okay, similar to logistic regression. It's between 0 and 1. And what you have is the probability associated with the input feature. If it's above 0.5, it's class 1. If it's below 0.5, it's class 0. Okay. And, why layers are needed? Because this is each layer is a processing step. Having multiple processing steps like allows you to capture complex functions, and it can basically implement any function based on the universal approximation theorem. So this is an initial forward pass here that you have here. So you have three features. Based on these features, it can be just the image of a car or something. Okay? You do all these calculations and predict like which car it is. Okay? It's an input forward pass, input layer. So you do sort of calculations, as I said, weighted sum of each input. This is your hidden layer values and output layer. Okay. Based on this output layer, which one is it? Is the car belonging to the Y1 class or the Y2 class?
Y1, sir. Y1, sir.
Yeah, because it has the higher value. Any other doubts till now?
The forward passed is a method or
It's forward passes moving from input to output. That is called forward pass. You basically do all these calculations. That is called the forward pass.
okay, sir.
Okay. To make it more easier, you have something called a weight matrix. Okay. Like multiply this input weight matrix by this vector, you get the values for H1. Same, you multiply this one by this weight matrix, you get the output for O1, O2, and so on. Okay. So this is how it moves. You have initial input, okay, multiplied by this weight, 0.2, 0.5, and so on. As you move through the weight matrix, you keep getting the value for H1. Okay, there's the mathematical formulation. Again, you don't need to worry about it. Like there is a package called PyTorch that will do all this automatically. For the next layer, again, this is the forward pass. At the end, what you have is a sigmoid function for each neuron. Sigmoid, again, it will scale the values between 0 and 1, smooth function between 0 and 1. And yeah, this will give you the probability, and based on the higher probability, you can select the class. That's it. But how do you determine these weights? Okay, because these weights essentially sort of give you the output. Okay, but how can we learn these weights? Anyone? Like, is it randomly given to you, or do you need to input every weight manually, or like anyone has any idea?
So it's based on how many features it have.
Hmm? No, how do you sort of input? Like, do you randomly start, or do you do you know the value beforehand, or
Based on distance, sir.
mm, yeah, some sort of distance? Like, how far is your prediction from the truth? Okay, so based on this, you sort of sort of learn these weights, I would say. You can do trial and error, but these, if you have a lot of features, it will take a lot of time because there are infinite number of combinations. So this is what I call as a loss. Yeah. The truth is this image is a car, but the initial prediction is this image is a bike. So the loss here is more or less. Can you calculate the distance, like Euclidean distance between bike and car? Basically, the loss is higher because the prediction is wrong. Okay? So, but if the prediction is right, the loss will be lower. Okay. So, how do we do it is something called gradient descent, because you start with a random weight, you come here, you keep traveling along this line and reach the minimum point. Minimum point corresponds to the minimum loss. Again, this is called gradient descent. You don't need to know the details. Okay. This is using something called the chain rule, and we skip this. And one more thing computationally you have to remember is you can't always, like, if your data set is huge, you can't do all the calculations in one forward pass. You have to like split the data set, do it in what I call batches, okay, to calculate the loss, okay, to speed things up. And this is what I was having about neural networks for today. So any doubts? Like, you don't need to know the mathematical details and everything. Okay. Maybe I can start with the tutorial. Let me just stop sharing. You all can start running things side by side. So we'll be using a package called PyTorch. Okay, this is by far the most widely used framework for scikit. For machine learning, it's scikit-learn. For deep learning, it's PyTorch. We'll start running, import some packages, and then here refers to neural network. Okay, you have a bunch of neural network layers. Let me first load the data set. Okay, and we'll see how the data looks like. Okay, this is different handwritten images of digits. So essentially what you have to do is give this as input to your neural network and ask it to predict if whether it's 3, 7, 9, 0. So from 0 to 9, you have to ask the neural network to predict the class. Okay. So since you have like more than 10,000 data points, okay, what you can do is split the data set. And this is where batch size come into the picture. So I'm using something called a data loader. Okay? This will load your data properly, okay, into different batches. So each batch will have 100 data points. Okay, you have to make sure that the train loader and the test loader have the same batch size. And since you are running the model across different iterations, you have to also shuffle your training data set. You should not shuffle your test data set. Okay. This is done. And so this is how you define a model. Okay. You set some input dimension. Input dimension is the number of features you have. Hidden dimension is the number of neurons that you want to have in the hidden layer. Output dimension is the number of classes that you have. So input dimension here will be 64 times 64 because it's a 64 by 64 image. Hidden dimension, you can set it to like 64, 32, 128 or whatever number you want. Output dimension should be 9 because we have 9 classes. Okay. And this is, you initialize first the input layer. This is what you initialize. You put an activation on the hidden layer, that is a sigmoid activation. So linear here refers to one hidden layer. And then you have the output layer, okay, another hidden layer that you have. Once you defined all this, I hope you're all familiar with classes and this there is also like functions and so on. So input will be X. This is in the forward function, you have to define your forward pass. Okay. In the input, first you pass from the passes to the input layer, put an activation function that is sigmoid. Once an output comes out of that, pass this output to the final output layer. Okay, this is how it works. So yeah, the output dimension is 10. I'm setting it to 100, but it can be any number. Okay. But if you keep increasing, you need more and more computations to do. Okay, so you sort of have to make a trade-off. The last function is called cross entropy loss. You don't have to worry about it, but when it's classification problem, it's cross entropy loss. When it's a regression problem, it's a mean squared error loss. These are some optimizers. Basically, this will help you sort of learn the weights, and you have to set something called a learning rate, which is a hyperparameter. Okay. Again, learning rate shouldn't be too small. It shouldn't be too large. If your learning rate is too small, you have to keep running the algorithm again and again. It will take a lot of time to get the best weights. If it's too high, then you won't get the best weights. So there's a trade-off. You have to set it somewhere in between. Typically, good choice is 0.001 or 0.0001, 3, 6, and so on. But again, this is a hyperparameter you have to tune. Now let's look at the model parameters. 4 input, 4 as output. So you have like 4 different layers. First input layer is this one, then is the hidden layer, this is the output layer, and this is the number of classes. Okay. And these are all weight matrices that you have. Okay. So you run this algorithm in iterations. So that is what is called an epoch. Epoch meaning like one single pass through the whole data set that you have. You do it in batches. This is where the train data loader comes in the picture. First, you get an image, you get a batch of images. Clear optimizer, this you have to do most of the time. You don't need to know like why do we do it. You do the forward pass, calculate loss, check if this loss is lower or higher. Accordingly, you also adjust the weight matrix, update the parameters, and while it's going on, you also calculate accuracy. Okay. As you keep running the algorithm, you see you run it 3000 times. The loss keeps decreasing. The loss keeps decreasing, meaning your model is predicting better and better. And as you can see, the accuracy also keeps increasing better and better. Okay. And when you run it, this is what you get. And you can add more layers in between, like the dropout layer or the batch normalization layer. And these are some things that you have to read through. Yeah, I've shared the notebook. Go through the notebook. Like you can change the hidden dimension to 200 and check, see if the accuracy is improving to more than 92% and so on. So, and if you have any doubts, you can ask me. Okay, I'm going a bit fast, but once you go through the notebook slowly, like looking at each line, you will be able to understand. Okay. Any doubts? Dropout and batch normalization are quite like more advanced concepts. Maybe like you can, if I can show you how to add dropout, you can also add batch normalization. Like you can add a layer like this. Okay. And then dot dropout PA0. Once you have the layer, once you set the activation, you can add another operation. Self dropout out. That's it. This is how you add a layer. And I want you all to add batch normalization also. Batch norm 1D. I'll let you define and run it. Yeah. Any doubts?
No, sir.
Okay. So I'll let you all run the notebook. I think you all have some exams coming up, so I'll finish a bit early. We'll resume from next Wednesday. We'll be talking about convolutional neural networks and recurrent neural networks. And then we'll also have a short project, and we'll be ending the course mostly before 10th or 11th. Okay. Any doubts?
Sir, optimizer. What is the use of optimizers?
Optimizer will get you, it will sort of tell you what's the ideal weight should be. It will get you to the ideal weight. Okay? As I showed in that curve, you have to keep coming down the curve so that you can get the optimal set of weights.
Okay, sir.
Initially, you don't know what's the best weight. So your loss will be high, accuracy will be low. So optimizer, when you keep running the algorithm, the optimizer will know, okay, if I change the weight to this weight, okay, my loss is decreasing. So it's a good weight. I'll keep moving in that direction. That's what the optimizer tells you.
Okay, sir.
Any other doubts? Okay. If there are no doubts, we'll end the session today. Go through the neural network notebook, and you can also try the same grid search CV for neural networks and see if it improves. That's it. Okay. Thank you. Thank you for the attendance. Maybe we can all have a doubt clearing session also sometime next week. Okay. Like you go through the course materials that have been taught till now. See if you have any doubts. We can also have a doubt clearing session. So
Okay, sir.
thank you.